So, hi everyone, I am Parampreet Singh. Some of you might know me from my Python or machine learning practices session, and this term I am taking revision sessions before quiz, end term, and OPP for revision plus practice sessions mainly. And last time, before OPP1, I did one MLP OPP1 practice session. This one, okay, and today we will be doing an OPP2 practice session where we will be doing mainly this practice set plus some questions of this one as well. Okay, um, so we will be covering both the parts, data pre-processing and model building. Okay, just one thing, the syllabus is different, not different exactly. OPP1 may you have from week 1 to week 6, right? In OPP2 you will be having, I guess, from week 1 to week 8 maybe. uh, the techniques will be same, just that there will be some additional models, like let's say some tree models will come, the XG boost and all, mainly tree based models, SVM and all these models. Okay, week 10, yes, these kinds of models will be there. Okay, but the concept, the implementation will be same. Okay, almost same. So today we will be mainly doing these two practice notebooks. Okay, and the recording of this session will be available in my YouTube channel. This is my YouTube channel. You guys can subscribe to it, or and after this session onwards, like around 8:30 or 9, you will get the recording here. Okay, so yes, also if you want to practice more, you guys can watch my previous session, OPP1 practice session, also the previous OPP sessions as well. Like this is my MLP playlist, machine learning sessions. Here you will find all the previous sessions as well. Okay, so then that's it. Let's start. Just one thing, please be interactive throughout the session. Okay, because we will be mainly, I know all the steps and everything, I have done it a lot of times. This session is for you guys, to so that you can practice more. So I want um a maximum response. If I get, that would be very helpful for you as well. Okay, इससे आपकी भी practice होगी, and if you let's okay, if you are on laptop or somewhere, you guys can simply go to my Kaggle account, kaggle.com/param302. This is my account. Okay, there you will find all the notebooks. Yes, um so the notebooks are public. Okay, there, just go to the code section, and there you will find the notebook. If I just write the practice OPP2, you guys can practice together as well. Just click on it and fork it. Okay, there you will get an option to fork the notebook or something like that. Okay, so let's start. First let me run this one. The dataset is downloading into the notebook. Okay, mainly today we will we will focus more on the model building part. Okay, because in last session we have focused on the data pre-processing part more. Okay, so this time I have decided to focus more on the model building one. So this is the practice OPP2. This is from the drive link which you might have received in the OPP1, for the OPP1 practice from the course team. This is the same notebook. Okay, now let's start with the data pre-processing. So if you have followed my previous sessions, or even if you have not, the first step, you you should know, which is the like loading the data set. Okay, so this is just the like path of my data set, the CSV file. So first I'll like load it here. Can anyone tell me how can I load the data set, the CSV file?
pd.read.csv.
Yes. Just chat. यहाँ पे numpy and pandas both are imported. Okay, already, so we don't need to import it again. Now let me write data. Let me zoom it. View. So I hope now it is like clear, much better. Is the font size clear?
Yes.
Okay. So pd dot read underscore csv there will pass in the our um, path of the dataset, and then okay, I think something is happening. Data dot height. Anyone can tell me what dot height this method do?
Print the first five
Distance of
samples.
Yes,
mm,
give the first 5 rows of our dataset. Okay, so these are the like first 5 rows. This gives us some sample of the dataset, like how our dataset is looks like. Okay, so here like the whole data description is written about each and every column. Our target column is price. Okay, price of the home. So this is our target column. Now let's like go ahead. The question one, this is like the very basic question. This is a free mark question. Okay, ये आपको जो भी data set मिलेगा, you just need to mark that. Now how many samples are there in the data set? Can anyone tell me like how can I get the okay, first of all, what are the samples, the number of rows or number of columns?
number of rows.
Number of rows. So how can we get the number of rows?
Data dot shape.
df.shape.
um yes, okay, yes, df dot shape I'm using data here, so data dot shape. This gives us a tuple of number of rows comma number of columns. Okay, so our number of rows will be 4000, which is the option A. Sorry. Now what is the average house price they are asking? Okay, now this is our price column, so I'll copy the name. Now can anyone tell me how can I get the average of this particular column?
df square bracket column name then mean.
Mean, yes. So mean function is used here to get the like average, and the average is same as written in the answer here. Okay, this is a very easy question, so we'll just like do it in very fast way. अगर किसी को इन सब में कोई doubt होगा, you guys can ask it. Okay, how many houses have 5 or more rooms? Now there comes the conditional kind of the filtration questions.
Uh, sir, I had a quick question. Can I ask?
Yes, yes.
Sir, so the recording will be started or it's going on?
It started.
Okay,
Okay.
thank you.
Now how many houses have 5 or more rooms? Now for the houses, rooms mainly, we need to check like which column is indicating. So okay, there is a column named RM which is for number of rooms in the house. Okay, so each sample is of a particular house. Okay, now the question is asking how many houses have 5 or more rooms. Okay, so if I write data rm, this will give me the number of rooms I have in each house. Okay, now can anyone tell me how can I apply this particular condition, like houses have 5 or more rooms?
Data.query
Mm-hmm. Yes,
and
with the
and
query as well we can do.
yes, square bracket means the codes rm greater than equals 5.
Yes, this is one way. Okay, there will get all the number of rows. um okay, so they are asking 5 or more rooms. Okay, So we need to like include the 5 number of rooms where number of rooms are 5 as well. Okay, so we need to include that as well. So now we are getting the answer here, which is like the number of rows you can see here, or we can simply do dot shape. We'll get 3925, which is option E. Similarly, we can do here. Can anyone tell me like this filtration method, the conditional column based conditions? Anyone?
eh, this should be greater than equals 5. Then we wrap to square bracket
Mm-hmm.
and then data.
Mm-hmm. Okay. Yes. So same, we'll get the same result. Okay, just that there are many ways to achieve the same result. Okay, in coding as well as in data analysis as well. Okay, so doesn't matter आप कोई भी method use करो, if the answer you are getting is same, then it's fine. Okay, there is no compulsion to use any specific method. Now what is the average price of the top 10 most expensive houses? Now this is a little bit different. First we have calculated the average of overall houses. Now we need to calculate the average, but of the top 10 most expensive houses. Okay, just before top 10, can anyone tell me how can you get the like the top first expensive house, the house which is having the which is the most expensive one?
Dot
We,
max.
So
We have to set
we can do
ascending
sorting.
ascending sort. Huh?
yes, we can do the sorting. Yes, that is a very easy way, but that is, you can say, time taking way as well. Like if you have, so here we have like almost 4,000 rows. Okay, 4,000 rows isn't much, but uh, rather than sorting, okay, there is a very easy way, which is n largest. Okay, if I do dot n largest and run this, I'll get okay, so this is for the room I'm doing, not for price. If I do this, so I'll get these values. What are these values? Simply the price of top 5 like houses who are having the top 5 maximum expensive houses, we can say. Okay, so the house at index 182 is the most expensive one, which is like 53 lakh something, then 52 lakh, then 52, and so on and so forth. So by default it gives me for the for uh, 5 largest. Okay, similar to head, we can pass any n here. If I pass 1, then I'll get the first largest. Okay, so there they are asking about top 10. Okay, this is the easier way which I am telling you. With the sorting as well, we can do, first we sort the data in descending order of price, then we can just take the first 10 rows and we can simply find out their average. Okay, there we don't need to sort anything. The n largest way will find us the n largest values of the specific column by its own. Okay, so if I pass in 10 here, I'll get 10. Yes, the recording of this meet will be shared in my YouTube channel. Okay, this is my YouTube channel, you can subscribe to it. Yes, okay, so this is giving me the top 10 houses, which are like the top 10 expensive houses. Now we just need to do the average, which is mean. This is the easier way, which I found it easy. You guys might found any other way easy, so it's okay. Okay, is this method clear? This way?
Yes, sir.
Okay, great. Now what is the total number of missing or unknown values in number of rooms feature? Okay, number of rooms, which is our data rm. Total number of missing or unknown values we have to find out. Can anyone tell me how can I find out the missing values? Okay, how do we find out, how can we get the null values or the count of null values? Yes, isn't it or is null, both are same. Okay, both works in the same way. So if I do is any, I'll get the false and so on. I can simply do dot sum or dot count anything. So I'm getting 0 here. Okay, 0 means there are no null values. But if I check one thing, if I copy paste it and here, if I do dot unique, so can you guys like see any kind of a weird value for the number of rooms? Yes, -1. Okay, so rooms cannot be negative, right? Or even if there would be any, अगर यहाँ पे कोई zero value होती, that is also not possible. Like 0 rooms in a house, that is not possible. So we take account of these values. Okay, so this is kind of a null value or unknown value we have in our number of rooms. So we just need to find how many of the values we are having with the -1. So we'll simply do data rm equals -1 and then dot shape. We are getting 68, which is the answer. Yes, we can also look at the min max using the describe. So if I do dot describe, I'll get minimum value as -1, which is obviously not possible. Okay, so this is like the one way to find out the unknown values. So is this clear to everyone?
Yes, sir.
Okay, great. Now what is the total number of missing values in the age? Again the same one. I'll skip this, okay, because the question is same, the method is same almost, just that we have a different column. Now the reverse side feature, this is a new different column because age and both are same, like both are numerical columns. This, if I see, this is a categorical column. Okay, now missing values they are asking. Yeah, value count I can do. Okay, value count. Okay, value counts, I guess. Yes, so here we are having a unknown name value in our reverse side, which accounts for 88 rows. Yes, so um, whether the house is on river side or not, there can be two values, yes or no. There cannot be any unknown or something. Okay, so this means this particular data is missing. Like 88 rows have the missing value for the river side column. So we have the answer 88, which is A. Okay, is this clear to you all? We can do the same in here as well. Okay, value count. It's up to you, whatever you want to use. Okay. Now, okay, is this clear to everyone?
Yes, sir.
Okay, great. Please interact with me throughout the session, just to keep it more engaging. How many houses are on riverside and were built within last 50 years? So I have done this question almost like 5 times till now. Can anyone help me write the code for this? It's very like common. Okay, how many of you have like practiced the OPP practice sets during OPP 1? Okay, so you might have like you might remember these questions. So these are of the one of the OPP 1 sets. Okay, the questions are similar. Yes. So okay, well ये सारे तो mainly same ही हैं. Should we move into this column transformer one, because this accounts for like a very, you can say, a big marks. Okay, ये questions
Yes,
मैंने पहले भी
yes,
करे हुए हैं.
yes. These questions are very basic ones.
Yes, okay, okay. This one should we do? Let me see the category. Okay, so we don't need the category column, we can skip it. So we need to do this, apply these pre-processing steps. So we need to apply these pre-processing steps. Okay, let's do this one. divide the training set into data set into training and test set. Can anyone tell me how can I divide the data set uniformly with these, like the parameters which they have given? 30% of the data is test set and random state as 0.
Using train test split, text size equals 0.3 and random should equals 0.
Right. And in which lab module we have the train test split?
Model selection.
Yes. Model selection, right. Import train test split. Okay, I'll
So
import it.
in
Yes.
in OPPE, every time we do this model section means the import and the functions or class name. Can we just do star and use
See,
the
there
method
are, okay,
simultaneously?
the star. I understood which you were saying something like this, from sklearn dot model selection
Yes,
import star, something like this, right?
yes,
This basically star means to import all the functions from this model selection module. Okay, there might be
yes,
like thousands of
yes,
functions, so सारे functions आपके पास आ जाएंगे which will be unnecessary, which will just increase your computation, the
yes,
compute. Okay, so just
yes, I know,
import the
but
required
in
ones.
OPP, it's very time consuming to go back to up and then import the function. So that's why
No,
I am
you
asking.
don't need to go back to the very first one. You can just do in the same, like the in the same question only. Okay, just like how
Yes,
I'm doing here.
yes, but that becomes very messy.
Okay, well, you can do at the end, it's up to you, but this is like a more conventional way which everybody do. Okay, this is
Yes.
readable as well, so at the end it's up to you however you want to do.
Okay.
um
Okay.
okay. Okay, first, before that, they are asking replace the respective missing or unknown values feature room count, riverside age with np-nan. So I'll do it in a fast way. Okay, rm dot replace -1 with np dot nan and data rm. Okay, then for the riverside, it was unknown, right? Data riverside dot replace unknown to np.nan. Then the last one, age. Okay, we need to see the age one as well. So if I simply do data, it was age, or yes, age dot describe. So we have -2. If I look for some unique value, okay, we have -2 only. I thought we have -1 as well. Okay, so we have -2 only. Okay, so what I'll do here, I'll copy this one, age -2. Okay, this part is clear to you, all right? These 3 lines of code, is this clear to everyone? We are simply replacing the unknown or missing values with np.nan. Okay, now keep the 30% of the data as just set, but before that, we need to like separate the target column. Okay, so what we will do is we'll write x as data dot drop. We'll exclude um, yes, so we'll exclude the price column. Okay, columns price, and we'll set it as for the y. So x represents like what are the training labels, y represent the target. Okay, this is the basic convention. Now we have the x and y. Now based on these x and y, we need to split our data set, okay, using train test split. So I'll write train test split here, train test split. So the first thing we'll pass x and then y, then random state as 0, and we also need to pass just size as 0 okay 3. So we need to pass in the ratio from 0 to 1, okay. The percentage which whatever is given, just convert it into the like decimal, and we'll get in the result in 4 parts. First is x train, okay, second is x test, third is y train, fourth is y test. Now okay, we have splitted it. Now they are asking what is the number of samples in the training set. Let me drag it here, okay. Yes, so x train, and we just need to do the shape. So we are getting 2800. Is this part clear to everyone?
Yes, sir.
Okay, great. Now we'll do this very interesting question, okay. Now drop category column, we have not created it, so we have to apply min max scaling, standard scaling, and some imputation as well, okay, then one hot encoding as well. So we have to do some different things. First, let's import all the things. For the scalars, can anyone tell me how can I import the scalars, the min max scalar, standard scalar?
Pre-processing.
Yes, pre-processing, import standard scalar. Think I'm writing. It was pre-processing. I guess. Then the min max scalar. Let me run this. Yes. Now we need to import the imputer as well, because we need to impute the missing values with some mean, median, and how can I get the imputer?
Impute.
Yes,
Dot impute.
impute, simple imputer. Okay. Now one more thing, one hot encoder. How can I get the one hot encoder?
I guess from the pre-processing itself.
Pre-processing only, right? So one hot encoder. Okay. Now just some more things I need to import. Just that you may have to use multiple instances of transformer. So we'll like create a column transformer. Okay.
You
And
have
we need
forgot to put comma.
yes. Okay, thank you. Will like, so there are like some steps need some column needs 2 steps, like this one, impute the missing values with median, then min max scaling, okay, like these 2 as well. So for these we need a pipeline, okay. So I'll import the pipeline, um, pipeline, and I need a column transformer as well, okay, which will help me to do all these things in one, you can say, in a large step. So now if I run this, I have imported all these. Now let's start each, okay, doing the column transformer one. Please everyone look carefully into all these steps. These are very easy steps, okay. हम एक एक करके सबको break down करेंगे. सबसे पहले let's take all the min max scaling columns, okay. What we will do, so I'll write here columns kind of, okay. I'll just write the name. So I need crime, and I need zn, I need poll index, I need dis, I need highway count, and I need tags as well, pt ratio, imm-bpl. So these are the columns which we need for the min max scaling, Okay, so I'm just like creating the list of the columns so that मुझे आसानी रहे. Okay, this is the way you guys can approach to it as well. Baki for the others we have like only one like column, like for the standard scaling only the index column, so we don't need to create a list again and again. Now what I'll do here is I'll create a transformer. Okay, transformer equals column transformer. Now here, okay, first we need to pass in a list. Okay, each list contains each step, whatever the transformation we need to do. Okay, each element in this list will contain that. Okay, and the transformation जो भी मुझे transformation करनी है, like these min max scaling or the standard scaling, I need to like enclose them in a tuple. Okay, how? Let's see. First let's do the min max scaling one. Okay, so first we need to provide a name. Okay, we can provide any kind of name. I can write scalar. Okay, then the second thing, I need to provide what transformation do I need to do. So I need to do min max scaling, so I'll simply copy it and paste it here. Okay, min max scalar, and I need to call it as well, I guess. Yes, we'll look into this. And then I need to pass in these columns जिन पे मुझे min max scaling करनी है. Okay, so this is like the one transformation which we will do, min max scaling on these columns जैसा यहाँ पे लिखा है. Is this clear to you all?
No, sir. Once again, please explain.
Okay, so the column transformer जो भी ये सारी transformations लिखी है ना, will do all of them in a one combined big step. Okay, which is using like column transformer. Okay, and like we have various kinds of transformation. One is min max scalar, one is standard scaling, one is imputation then min max scaling, one is like imputation with mean then min max scaling, and the last one is most frequent then one hot encode. So हमारे पास 5 types के different transformation करनी है ना, in our data set.
Okay.
Now we will do each of these transformation, we'll write each of the transformation here. So we need to like call this a column transformer. We need to pass a list of all the transformations जो भी मुझे करनी है, and each transformation is a tuple mainly. सबसे पहले we need to provide the name, then जो भी करना है हमें process min max scalar will pass in that, then जो columns पे करना है वो column names. Okay, we need to pass in them as in a list. Okay, so वही I'm passing the list here. Now is this clear?
Yes, sir.
Okay, is this clear to everyone? Okay, great. Now let's move ahead. Now we need to do the standard scaling. Now you guys tell me for the standard scalar, what should be my first step? Anyone? You guys can try, कोई भी guess कर लो. Okay, it does not need to be correct, just try something. Okay, at the end आपको ही करना है.
Sir, a string name, comma the object.
Yes. Standard scalar, SS scalar, anything we can do. Okay, I'll write standard scalar. First the name. Okay, then the particular object which is the standard scalar, and then we need to pass in the column. So how can we pass the column? Okay, so we only need like we only have one column which is index. Okay, for standard scaling. So how should I pass it? Just directly in this manner, or how? Is this right? If you
So
have,
it should be in a list.
it should be.
In a list.
Yes, it should be in a list. Okay, I'll just enclose it in a list. Okay, so this is the syntax mainly. आपको syntax ही थोड़ा सा मतलब वे याद रखना है. how like it is how you have to do it, just that, and ये आपको practice से हो जाएगा. Now so ये सारे हमारे cover हो गए. Okay, now we have these three. Impute with median, then min max scaling. So there are two steps for the room column. Okay, similarly for age and riverside. Up we can't do these two steps independently, like imputing the missing values with median, and for some we are doing min max scaling. We have to do it in a order, right? First we need to impute the missing values. Okay, replace the missing values with the median, then we have to do the min max scaling. Okay, after the imputation. So how can we do this? We'll create a pipeline. So I can simply write rm pipeline. Okay, now this will make our code a little bit bigger, you can say, but just be with me. So what I'll do here, I'll initialize a pipeline here. Okay, so this is my pipeline mainly. Okay, यहाँ पे.
So
Yes.
can't you you make this pipeline outside of the transformer and then call
Yes,
it?
yes, we can I can do
Okay.
something like this as well. Yes, so I'll do it here. This is, if you find this easier, we can do in this manner as well. Again, we'll pass in the same manner. Okay, first is imputer, and here we'll pass in simple imputer, and the strategy is median. Okay, then I think that's it. Yes. Then the second part of the pipeline is we have to do min max scaling. Okay, so mm scalar, and here I'll pass in min max scalar. This is it. So if I just like show you this pipeline, so this is how our pipeline looks. So there are like two main things: simple imputer and the min max scalar. Okay, so these are the two steps which we will simply pass in here. Again, this will make our code very much simpler. Now we just need to pass in the column name rm. Okay, similarly we can do for the other as well, which is the age. Now for age, you guys can tell me like about how can I do the create a pipeline for this. So we need the mean and then min max scaling. One step is same, just that एक थोड़ी सी changes करने हैं हमें. Anyone?
So
We can like set strategy as mean, or we don't need to set the strategy as mean, because by default the strategy for a simple imputer is mean only. Okay, so this is how our age pipeline is created. Okay, are these two pipelines clear to you all? What about others?
Yes, sir. Yes, sir.
Okay, great. Now I'll pass in this pipeline here as well. Okay, now one last pipeline I need to do. Which is this riverside. Okay, I'll copy this and I'll like create it here. I can just simply name it how I want. Now a riverside is our categorical column, so we cannot compute mean or median. We can compute mode, which is most frequent. Okay, then we need to do one hot encoding. So I'll write one hot encoder here. Okay, OHE or simple OHE one hot encoder. Is this clear? The river pipeline.
Yes, sir.
Okay, now I'll pass in here river pipeline and river pipeline, and here the column name, which is riverside. Okay, and this is it. Just that now abhi to we have covered like all these columns, but sometimes what happens is we don't need to do any kind of transformation in some columns. Okay, so we need कि हमारा ट्रांसफॉर्मर उन कॉलम्स को स्किप लाइक ना कर दे, मतलब it does not, like it should not ignore those columns. Okay, by default if we just do this, then जो भी columns हम transformation नहीं कर रहे, it will remove them, but we do not need to remove them. What we can do is we can set reminder remainder equals pass through, which simply means all the remaining columns just pass them as it is. Okay, this is it. We have like these transformers. Okay, and now if I run this, okay, so I'm getting okay, I need to set it like add a comma. Yes, so we have these like different transformers. Is this clear to you all, the column transformer?
Yes, sir.
Okay, what about others? It would be great if I like get a thumbs up or anything, just like if it is clear. Okay, great. So this is like easy, it is not very complex or something. थोड़ी सी practice करो, सब हो जाएगा. Okay, now we have applied these pre-processing steps. We have created the transformers, we have not applied yet. How many features are there after performing above transformation? Okay, now we have to perform this transformation. How we will do is, so on training and on test set, we on both of them we have to do. So I'll create a new like TF kind of a data set, which is the transform data set. I'll write transformer a dot fit underscore transform. Okay, then yes, that's it. There I need to pass in the data. Okay, now same I'll do here for the test one. Okay, transformer dot fit transform x test. Now there's a mistake which I am doing here. Can anyone point it out?
You have to just to fit. You have to just to transform only.
Yes, so on training set only we do the fit. Okay, basically fit is for computing all these minimum maximum values and all the values. Okay, transform means to transform the values. So हम test set पे we never do the fit. Okay, we never compute the values, we just replace those values, we just transform the data set. Okay, so on training, we need to do both fit and transform. On test, we just need to do transform. That's it. And now if I run this, so my transformation is done. Now how can we see this? See the transformation. I can simply see x train tf if I run this. So I'm getting this array here. Now this is like a very, you can say, how can we see which so this is basically a matrix. Okay, this is first row, second row and third row and so on, but we don't know like the column in each row is representing which column, we don't know exactly. Okay, this is an array, we have passed a data frame, right? If we want a data frame back, so then what we can do is here I have like we have a get feature names out or something like that. If I put a question mark here, I'll see yes, Gyan.
So in the transformer itself, we can uh, uh, use the attribute dot set attribute and then in square brackets transform equals pandas. So it
Okay,
gives back the data frame itself.
okay, what is the attribute name?
So set uh, output.
Okay, set output. I cannot see it here. mm, Here you mean, right?
No, no, sir, here not in the square bracket and then dot. No, no, so
um
in the parentheses, parentheses then dot.
Here,
Yes, yes, sir.
set output.
and then parenthesis transform
Okay,
equals pandas.
pandas. Okay, so this was something new. Uh, okay, if it works, then it's great. Okay, so I'm getting a value error here. Pandas output does not support sparse data. Okay, so the data is like our data is different, so it is giving us this error. I think there is some yeah, we have feature names out or something. We
So
have
in the one hot encoding object, there is called sparse output. There you have to
okay,
put false, I think.
okay. Yes. I remember. Sparse output false. Okay, great. Now it worked. Now let me see our training dataset. So we got it. Okay, that is interesting. Last time I have just like extracted all the feature names from like an attribute, and I have created the data frame manually. Okay, so this is a very interesting way. We got all these features. Okay, the data frame itself now. And similarly we got this for the test as well. And thank you, Gyan, for this thing. Okay, I think I have done it earlier, but I don't, maybe I have done it very less time. So mainly what I do is I extract all the feature names and just set it, create a data frame afterwards. Okay, now we need to tell how many features are there. So the number of features will remain same in the like training and test, right? है ना? Number of features will be same, just that the number of rows जो different है उसो है. The previous are like our data set before the transformation, it contains some feature names, and now our transform data set, it contains some extra feature names. So there the features will vary. Okay, but the features in both the transform training and transform test set will be same. So we can check for any. Now if I do shape, I'll get 14 here, which is the answer. Okay, very simple. Is this clear to you all? Okay.
Yes, sir.
If anyone has any doubt, you guys can ask, or we can move further. Okay, I think not. Then let's move ahead. And now it is asking what is the mean of the transformed test data features only. Yes. So we need to compute the mean of the test data. X transformed this one. So can you guys tell me how can you calculate the mean here? Just a very basic.
Dot mean.
Yes. So dot mean, first what it will do is it will calculate the mean of each column. Okay. Then we need to do mean here again, which eventually like calculate the overall mean. Okay. Now we are getting here which is the same answer as here. So this is very simple. Okay. Now this is our like data pre-processing part. This was, it is done now. Has anyone any kind of doubt here? If anyone has any kind of doubt, we can clear it out, or then we can move ahead for the model building part. Okay, I think not. No one has any doubt. Then apply PC on processed uh, training matrix only. Do not transform the data. What is the value of largest eigenvalue? I guess this question was in this one. Okay, so PC apply करना. It's very simple. We can do it here. Now for PC, how can we import the PCA?
Feature extraction.
Yes, feature extraction, import PCA. Okay, there was, okay, let me check it with PCA scalar. Okay, decomposition. Okay. It was decomposition. Okay, so we got the PCA here. Now on the process, not do not transform the data. Okay, now we have the PCA here. We need to apply it on our like PCA equals PCA, and in components they have not provided like how many components should we set here. What is the value of the largest eigenvalue? Okay, so PCA dot fit transform x train TF. Now we have done the like we have applied our PCA. Now to check the eigenvalues, I forgot the exact name. uh, uh, um, yes, so explain variance, right? um PCA dot explain variance. So these are the like eigenvalues which we got. Okay, what is the value of the largest eigenvalue? So we can simply do dot max here, and there will get okay, this one. Okay, this is the variance for it. This is the variance for it. Eigenvalue. If I check here, and components, features, sample, the singular value corresponding to each of the singular component. I maybe it was okay. Can anyone tell me like how can we get the eigenvalues from the PC? I guess the question is, I'm not sure about the question. Okay, components. I'll get the components is singular thing. Okay, need to check it here. Singular value. Feature names and all these things. PCA dot singular values. Okay, so we got this the singular values which are the eigenvalues. So if I do max here, and we got this 57.0.8, which is the answer. Okay, so to get the eigenvalues we do singular values. Okay, okay, this is something new for me. So yes, a very basic question. See, the same I have tried, which I must have done in OPP as well. अगर मुझे कोई new question encounter होता है, what I do is simply like basically we need to know which parameter is returning what value. Okay, so what I am doing here is just putting question mark here and then the particular transformer or whatever we are applying. Okay, then it will give me whole the, you can say, the a doc string, okay, of that particular function method or something. So here they have written like this is the basically documentation, you can say. So there they have like provided all the attributes. So we have the components, explained variance, variance ratio, singular values, and all these things. Okay, so we can use this. Now if you eliminate one feature with recursive elimination, so this is very simple recursive elimination. Should I do this or should we move ahead? Okay, anyone, guys, please respond.
Sir, you have done in previous OPPE.
Yes, that's why I was okay. Now This is for this training set and all. Okay, the data set is I think same. I click here. Okay, I think the data set is same, so I just need to do the train test split here. Now so we have like these x train and x test, so I need to merge it first. So x train tf can do pt dot merge and x test tf. Think it will. Okay, I need to pass in, so um
So what if you use pd.concat?
a pt dot
Concat.
concat.
Yes.
Okay, if I pass in here x train tf and
So
x
it must
test.
be in a list.
Yes, it will be in the list right. So yep, I have these values now. Similarly now I'll do for the y as well. So this is my x and then y pd dot concat y train tf and no, y train simply y test. So we have x and y here. Now we need to split it into with the random state 0.42. Okay. Now let's split it. Okay, train test split. Here I'll pass in y random state as 42 and the test size is 0.3. Okay, again x train x test y train y test. So I have this data now. So now I need to train the ridge model on these parameters. Okay, ridge model. From which library should we import the ridge model? From which module?
Linear model.
Yes, linear model. Linear model import ridge, and now I have the ridge here. Now I'll just train our model. Okay, model equals ridge and I'll pass in alpha 10 solver saga tol. This is the default value. We can pass it if we want. If we do not, we can ignore it as well. Random state 42 model dot fit x train and y train. We have fitted our model. Okay, we have trained our model. Now we need to check the R2 score. If the score differs, this is simply mean like the data set is different. I'm just using the same data set. What we will do here, model dot score. Okay, so by default all the linear models on the regression, like all the regression linear models, they uses the R2 score as in the score method. Okay, so we don't need to import R2 score externally. Now model dot score, here we'll pass in two values, which is the prediction and the true value. So y test and model dot predict.
So it should be X test and Y test.
Okay, if I check, yes, okay, yes, sir. Now I'll simply pass in x test and y test. So if I run this, I'll get here. Okay, the answer is same, 0.6651. So this is our R2 score. A very basic question. There is no like a bigger thing, and it is of 7 marks. Very basic. I hope you all are like clear with this question. Now these are some interesting questions. Index of the most important, least important feature. So the importance of the features, we get it via their coefficients value, which are their weights. Okay, just one thing, if I do here model dot coef. Okay, so these are the coefficients, these are the weights which I'm getting. We just need to do the absolute of them, which is all the values are in the positive. Now the feature which is having the highest coefficient, highest weight, like this one, this means the feature at this particular index, जिस index पे ये value है, okay, that is our most important feature. Okay, and the feature which has the lowest weight, something we can say like this one, this means कि इसकी सबसे कम importance है, okay, in our model. Now how can we get this particular index? We will do argmax, um, I think it's argmax directly, not argmax. Yes. Okay, so we are getting 8, not 9. I don't think it is the index of the most intercept. Index starts from 0. Okay, yes. Most important feature तो हमारा यही होना चाहिए. Okay, I'm getting a different answer. I don't know why. It should be like the general way is this one only, argmax. So if I do max here, I'll get 23 point something, and to get the index, I'll do argmax. Yes, Gyan?
Well, it could be because of the database, because of the data, it may be possible that the feature is shifted, means the
Right, right, right.
column. Yes,
Yes, that is possible. That is possible.
yes.
Yes. Okay. So I have not downloaded the exact data set, but the data set is same, just that they have like transformed it in a different, like the feature names are jumbled, shuffled, you can say. Okay, so this might be the only cause. Yes. Now next one is the least important feature. Now for the least important, what we will do here, we'll simply like check for the minimum value. Okay, so argmin gives the minimum index of the minimum value, which is here we are getting 9. I think the features are shuffled, that's why this is happening, but the overall like the implementation is same. Now SGD regressor, this is an interesting question. So take SGD regressor with grid search CV. Anyone can tell me what is grid search CV?
It is a hyperparameter tuning method or
Yes,
module.
yes, yes, it is a hyperparameter tuning method, which is like if we pass in various values of various parameters, it helps us find which parameter is the best, okay, by applying all the combinations of all the parameter values. Okay, so like we have these values, mainly these three values. Now first we need to define the parameters. Okay, so penalty as L1, L2, alpha 1e5, 1e minus 4, 1e minus 3, 1e minus 2, 1e minus 1. So these are the values, and tolerance values are okay. So this I'm like creating a dictionary of all these values. ये जो यहाँ पे 3 points है ना, same these values. 1e minus 3, 1e minus 2, 1e minus. Okay.
So for
Yeah.
this also, I have I have found a simpler way that use the dict keyword and then put this value in the equal sign, so we
Yes,
don't
yes,
have to
yes.
put the double quotes and all.
Yes, we can do that. In the
Yes.
dict, like in this dict function, okay, which is the dictionary itself, we can pass in the key and values as in the like arguments, जैसे हम function में parameter pass करते हैं ना,
Yes.
the named parameters. Okay, in the same manner we can do this. It's up to you. Now for the grid search CV. Grid search CV is in from SQL and dot. Okay, it is in, I guess, model selection. Grid search CV and SGD regression also will be import. So where is the SGD regressor?
Linear model.
Yes, linear model. SGD regressor. Now we have the parameters here. Now we'll simply do uh, I'll simply write CV here, grid search CV, and there first I need to pass in the model, which is the SGD regressor, and random state as 42. Now the parameters which I want to pass, the CV value is 5, which is the cross validation. Scoring is negative, mean, absolute, error. So neg mean, which is the simply mean, absolute, error, just that the namings are in the with the prefix neg. Okay, negative. Now CV dot fit x train, y train. So now it is like running our model on like all the combination of all these values. Okay, and this gives us like the best model, we can say. Now they are asking for the what is the best penalty. So for getting the best parameters, like सबसे पहले it will take L1, then it will take these values, then it will like train our model, then it will take this value, and this value, then this, and this value, and similarly it will take all the combinations and create like the model. So here we have like 4, 5 and 2, so it will be 40 different models. So it will create 40 different models, and out of those 40 different models, whichever has the lowest mean absolute error, that it will consider as the best model with the best parameter values. Okay, so this is what hyperparameter tuning. Yes, Gyan?
So, does it also train models for the CV means for the different set of data
Data,
means it,
yes, with the
yes,
CV
yes.
equals 5, it is doing cross validation 5 times, which means it is for each model, like there are 40 models. Okay, for each model it is doing cross validation 5 times. Okay, that means it is splitting this data into 5 different sets and doing training on them. Okay, so this is the thing. And now for the
Okay.
best, yes,
So in total, how many models are being trained? Means 40
into
into
5,
5
1
or
2,
something else.
40 into 5.
Oh,
mainly
okay, okay, sir.
mainly you can say 40. Okay, because the CV, it will take the average of the CV values. Okay, because the CV is just for the cross validation, it is like for the confirmation, you can say. Okay, but the parameters, distinct parameters will be like in the 40 models. Okay,
Okay,
now
sir.
CV dot best params and underscore, this will give us the best parameter values. So now penalty as the best parameter is L2. Okay, so this is what we are getting here. I can simply write here penalty, and we'll get the best parameter value, which is L2. Is this clear to everyone? Okay, किसी को इसमें, if you guys have any doubt, we can like clear it. If not, we can move ahead. Okay, I think it is clear to everyone. Now let's move ahead. Mean absolute error on the test dataset. So we'll take the CV best model. I think it's okay, not best model. It was
So best estimator.
yes, best estimator. Best estimator. This is our best estimator. It is already trained on the values which we got via the best params. Okay, parameters. Now we'll need to check the score. Score x test y test. Okay, so we are getting a different score here.
So should should we import the mean absolute error and then
I think
compute
yes,
the
yes, that is,
score?
I'm like confused. I think it is checking the R2 score. So if I import
Yes,
from
yes, yes, exactly.
sklearn.metrics, import mean absolute error. Now if I run that, mean absolute error, y to y model, okay, cv.bs estimator dot predict exchange. Okay, now we are getting the mean absolute error, which is the same as the answer. So this is the way. Okay,
So
this is very easy. Yes.
what if we just do cv dot predict?
CV dot predict. It by default also it takes the best estimator. Okay, so
Okay,
if
sir.
I check with this CV dot predict, x just or dot, let's do CV dot score, x just y test, and CV dot best estimator, x just y test. So yes, it is taking the average of all the, okay, it is taking the average, but okay, no, it is taking the best estimator only, but with this scoring which we have used here. Okay, so here we are doing the scoring on the best estimator. The estimator has the different scoring, but the overall grid search CV has the different scoring. Okay, so yes,
Okay.
in any way we can do from both of these ways. Now this one, this last question, create using grid search CV, PCA and lasso we need to use. So I'll import lasso here, from sklearn.linear model, import lasso, and params has, okay. Now there are two things which we need to do. Okay, we have a like pipeline as well. So first let's create a pipeline here. Why pipeline? Because we have a PCA as a transformer, then lasso as an estimator. Pipeline, and first our PCA is there. Okay, and then we have lasso, which is the estimator. Okay, I can simply write ESG and lasso. So we have our pipeline here. Now on this pipeline we need to do grid search CV. अभी यहाँ पे तो we did it in a very basic manner. Okay, let me just copy paste these parameters. We need to use different parameters. For n components in the PCA we need to use these two values. Now can anyone tell me how can I set the n components value? 0.9 also? Yes, 0.9 comma 0.9. Is it right? Like the n components for the PCA.
No, we have to put the string and then double underscore.
Yes. So simply in the pipeline we have various things, right? We have a transformer, then we have an estimator. So when we do grid search CV on this pipeline, the grid search CV doesn't know like ये n components किस में डालने हैं, for the PC or for the lasso. That's why we need to specify that like the name of the step in the pipeline step, on which step we need to pass in this n component. Okay, so we need to pass it in the PCA, and then PCA and double underscore, this is the simple convention. Okay, you can say, to pass in the values. Now then for the estimator, and I can write any kind of name here. The name which I write here, I need to use it here as well. Okay, in the parameters, and here I'll write alpha. Okay, because the alpha values which it is taking 0.01, 0.001. So these are the parameter values. Now if I do lasso CV, I'll create grid search CV, and here I'll pass in the pipeline and then params, and CV equals 5, n jobs minus 1. N jobs is simply -1 means to take all the process, all the like take use the CPU, you can say use maximum of the CPU, so it takes all the not threads, I forgot the name. It basically uses the cores, yes, to use all the cores of the CPU to do the computation, so it do it very fast. That is why we use n jobs -1. Then scoring is negative mean absolute error. Lasso CV dot fit x train and y train. Now it is fitting the model on these values. Now we have got an error which is invalid parameter alphas. Okay, so we cannot, okay, we have alpha not alphas. My mistake. Now if I run this, so it is now okay, it has now completed the training, which is very fast. Now it is asking if we fit the pipeline on training dataset, what will be the R2 score on the test dataset. What we will do, lasso CV best estimator dot score x test y test. So we are getting this R2 score, okay, which we just seen, like the estimator by default uses its default score method, okay, but the scoring which we have provided here, it is used for the grid search CV mainly, okay. Now we have got this which is the same R2 score. Now how much variance is explained by first principal component. Okay, now this is something interesting. We need to get the the explained variance which we use in the PCA. Okay, we need to get the variance explained by the value of variance for all the components which you have in the PCA. But how can we get it? It is in the pipeline. Anyone knows? Okay. If I do, okay, so lasso CV best estimator, if I write it, so I'll get this pipeline, right? This is the best estimator, or you can say the best pipeline. Now we have this pipeline here from the lasso CV. Now we need to get the first principal component. So principal components are in the PCA. Okay, now here what we need to do is we need to write, I can simply write named steps. Yes, so the named step, it gives us a dictionary, whatever the values which we have passed here in the okay in the estimator, but I don't need that exact. Yes, now I need to get the PCA object here. Okay, so what I'll do, I'll write PCA here, okay, in small. So now I got the best PCA which is used in the overall grid search CV. Now this is a PCA, and simply अब हमारे पास PCA आ गया. Now I'll simply write explained variance, and this is the explained variance we got, and now explained by the first principal component. The first principal component is at index 0, which is this. The answer is same, 1.1616. okay, so let me explain it again. First, this grid search CV is using the pipeline. Okay, this pipeline is of 2 steps, and it is doing the hyperparameter tuning for many parameters, right? First we need to get the best estimator, which means the best pipeline जिन पे हमारे the best parameters value which we have for a pipeline. Okay, when we got that pipeline, now each pipeline has a method called named steps. Not a method, it's a dictionary. it basically contains these name as the keys, okay, PCA ESG, and its respective object, like the PCA which we are using here, the estimator, lasso and all, as the values. Okay, तो मेरे पास best estimator आ गया. Now I need to get this PCA. So using this named steps PCA, I am getting this PCA. Okay, then just simply explain for the how much variance is explained, we can get via explained underscore variance underscore. This is the method of PCA itself. Okay, this is not like very confusing or something. If you break down each and every step from a PCA, if you want explained variance, you do this one. Okay, from a pipeline, if you want the PCA, you do this step. And from the grid search CV, if you want the best estimator, or you can say the pipeline, we do this step. Okay, so I've just combined each and every step to reach it to the very end. Okay, is this clear to you all?
Yes, sir.
Okay, the main thing is, see, it is of 7 marks. Why they have kept it of 7 marks? Basically तो बहुत easy, we are not doing any kind of calculation. They just want us to like use these steps mainly to get the value. Okay, they just want to know ki how we are approaching to the best estimator and getting the explained variance. So the like this very one line of code, you can say, is for 7 marks. Okay, the value, obviously the value is okay, not the result, you can say, is the main motive here. The approach is the main motive here. Okay, how you are approaching the problem. So this is the way to approach it. Now we have this polynomial features. It is very basic. Should I do it or should I skip it?
So you can skip it.
Okay, then I guess we are done with this. So how much time we took? I think 1 hour or 1 hour 20 minutes maybe, right? And OPP कितने टाइम का होता है? It is of 120 minutes. 2 hours, right? 2.5
No,
hours.
yes,
Okay, so we have done it in like very less amount of time, which is
but
just,
yes,
yes.
in this time the pre-processing and the regression model, classification model, uh, three things will come in the OPPE.
Can you like uh, can you repeat please?
It this time the pre-processing and linear model building as well as classification model building, these three all things will come.
Yes, that will come. Yes, classification is also there. Okay, I have not, like we do not have any kind of classification models here. We have added it here mainly. Okay. Yes, this one. So the KNN imputer with all these other as well. Randomized search CV, PCA, ridge regression, and other SGT regressor, K-fold. Okay, I have these questions here. So mainly, see, the thing is, you will get the pipeline, you will get the like grid search CV, the column transformer, these kinds, like these transformers, you can these transformers or these module, basically जो भी हमारे concepts हैं. Okay, the concepts will be same, the models will be different. Like instead of PCA, here we have polynomial features. Okay, the feature selection or any kind of it, or the models will be different. Like here we have lasso, it may be ridge, it can be decision tree, it can be anything. Okay, so there are like many number of combinations. We cannot obviously do all of them, but we can do most of them. Okay, I've just shown you like a one way. Of course it may have kind of a less questions, you can say 9 here, it will be like 12, but still we did it in a very fast manner today. uh, well, I have this extra notebook which I always recommend it in every OPP session to practice with this on your own. Okay, so there are many questions here, like 18 questions for the model building, which is enough if you see, and the like 16 questions for the data pre-processing as well. So you guys can practice on this as well. For me, like, it's just the same thing. It will not be like something new. Or yes, Gyan?
Sir, should the answers only in the uh, notebook? It will be very much helpful to validate if the answers are correct or not.
See, notebook में ऐसा कुछ लिखा नहीं होगा if your answer is correct or not. Okay.
No, no, I am saying to put in this notebook the answers in this notebook.
Okay, the answers.
Yes.
Okay, all right. I'll put it. Well, answers के लिए I have done one more. This practice set one. If you see, I have done this one. Okay, so it is again the same practice set, but with the different questions. Okay, so you can see, like, here I have used the same methods, uh, like as we have done here today. Okay, the data set is different, of course. The combination of questions are different as well. Okay, some are same, like the polynomial features, lasso and all, we can see. I'll try to solve this, and if I solved it, then I'll like add in all the answers here. Okay, मैं answers यहीं पे add कर दूंगा. Okay, but I would recommend you guys to try it on your own. अगर किसी को कोई भी डाउट आता है, yes, अगर किसी को कोई डाउट आता है, you guys can just comment on the video. Okay, I'll upload the recording of this session in my YouTube channel. Just comment on the video in which question you are getting the doubt. I'll simply solve it and provide you the code with the explanation. Okay, just that it will be again the same thing which I'll do here, nothing new. If you want to clear any kind of concept, I can do that, or something which you think is not done or which is important, or anything if you want to know. Okay, have you guys like got an sklearn quick reference guide or something during the OPP one? Yes. Okay, the similar that PDF you will get again in OPP2. Okay, that will contain the table having like what each module is having, like where do you have the grid search CV, where do you have SGD regressor. Okay, so you don't need to go to the documentation and check where is it. Okay, you can just follow that reference guide. Okay, तो आपको वहाँ पे सब कुछ मिल जाएगा. And one thing जो which I have done it here as well, like sometimes we don't remember what parameter exactly we need to use, the one which I forgot during the PCA one, right? So what you can do is you can use that specific object. Mainly collab पे तो ऐसे भी आ जाएगा. We can either use help. Okay, if I write here PCA which I have imported, help and PCA, I'll get this whole documentation. Okay, here we can use we can do in this manner. Okay, well, this is very long. Or we can do there is another way. Instead of help, what I'll do here is simply put question mark then the object name. Okay, that's it, and it will again give me the same documentation. So इससे आपको पूरा clear हो जाएगा. Like if you see here in the attributes, so explained variance gives us the how much amount of variance explained by each of the component. So it is giving me like it has the whole documentation. Okay, and it is allowed. ऐसा कुछ नहीं कि it is not allowed. So yes, you guys can use it and take benefit of it. And one thing, I guess collab में auto completion on है. So if there is an auto completion, if it is enabled, use it, but don't generate the code. Okay, code generation मत करना, use the auto completion. If you use the code generation and all, it will be logged in. So हर एक notebook है ना, logs create हो जाते हैं, like whatever the step you are performing. If they manually check your notebook, if they found it, then you might like be marked as plagiarized or something. So refrain from doing like generating the code, rather just use the auto completion. which is there by default in Collab. Okay, that will be helpful for you as well. Okay, and yes, spent less
Where
time on
can we
training.
set this feature? Where can we set this feature?
Which feature? Autocomplete is only for variables in
Yes,
yes.
auto completion and
It is like it is enabled by default in all the Collab notebooks. Okay, जो आपको Collab मिलेगी ना, it will be there by default. Okay, so ऐसा कुछ there is no specific setting to turn it on. And okay, let me save it. I'll share this as well. By the way, there are like many more practice notebooks I have in my Kaggle profile. Just go to kaggle.com/param302. Okay, and go to code section, just write MLP. You will see a lot of notebooks for all the sessions and all these. Okay, and I'll like share you guys this notebook as well, and plus this practice notebook, both of these practice notebooks in the video description. Okay, and yes, that's it. And before end term we will take a revision session as well for the end term, just to like help you all. If you guys have anything to ask, you can. If not, then let's conclude the session.
Thank you, sir.
Okay, welcome.
sir, that link for Kaggle account is shared by you.
Okay, let me share it. Welcome. Let me share it. So yes, and yes, the recording of this session will be available in my YouTube channel just after this session. Okay, after a few minutes. And all the best, guys, for the OPP2. And okay, let me pause.